There's three basic things that I'm going to tell you with any trigonometric sum that you want to do. Number one, your first step is always get the angles between 0 and 360. If the angles are negative, you get them positive. If the angles are larger than 360, you subtract 360s until you get them between 0 and 360. That is always step one. Step two is use reduction formulas or cofunctions to get your angles between 0 and 90. So that's your second step. Get your angles between 0 and 90. Then your third step, ladies and gents, is now where the trick part comes in. It becomes a bit tricky because I'm going to say the following. I've got a rule of thumb. The rule of thumb is the following. Do not make your sum larger unless you've got no other choice. Okay? Always try and make your sum smaller unless you've got no other choice. Then you make it larger. Please, please, please remember that. I'm going to say it quite a few times to you today. Because what I have found in my experience, and those of you that's tuning in via the live streaming will also relate to this, a lot of you guys run into a trig sum, you try and do some fancy magic, and then halfway in the sum you have no cooking clue what you've been trying to do, but you know you are further away from the solution than you were at the beginning. And then what do you guys do? Skip to the next question. Okay? Or you try and manipulate that thing until you basically pass out and you've got about a 3/4 of a page that you've done on a 3-mark question. So today we're going to work through that, but before we do that, I'm going to throw you into the deep end by asking you guys to simplify the following trigonometric expressions. If I look at cos squared 180 plus a times by tan of 360 plus a over cos of 2a plus 90, sorry. And this is times by tan of 315. My step one, again, understand the way I approach trigonometry. I go very systematically. I approach it, number one, get my angles between 0 and 360. So this one is too big, so all I do is subtract 360. So this, all the rest, I leave the same for now and just subtract 360, and my answer is tan of a. Okay? There we go, ladies and gentlemen. Now, next up, I ask myself, okay, but my angles are not between 0 and 90, so now I reduce them. So this one is simply in the third quadrant because of the 180 plus. And now I know there's quite a few of you that unfortunately did this. And if you did that, unfortunately, you lose your mark, sunshine. Oh, I'm talking to you. Guys, be careful. That square counts both for the negative as well as the cos. We will try and catch you guys out with that. I guarantee you guys. Now, tan of A is absolutely no worries at all. Now, the 2A plus 90. Again, some of you went and applied the compound angle identity. Please don't. Now you guys are going, but that was my only thing I did right. Guys, listen to me carefully. For those of you that struggle with co-functions, because this is a co-function, I'm just putting it out there. Remember, your co-function rules according to the cast diagram. Here I work with 90 minus, here I work with 90 plus, and there I work with minus 90. If you've never done it this way, it's now a good time to start. The 90 tells me cos changes into sine. Sine of 2a. But the plus 90 tells me I'm working in the second quadrant where cos is. That's how you get it in a short way. Okay? I want to quickly ask you guys this silly question. And I'm saying it's a silly question, but it's an interesting question because especially those of you that do AP maths, you know that you've got to do the co-functions of the inverse functions as well. And now you guys are going, okay? Ladies and gents, let me make maths very simple for you. What is the co-function of sine? If I look at co-functions. What is the co-function of sine? Someone quickly tell me. Cos, right? How did I get that? My teacher taught me, okay? Guys, between you and me, that is what the co stands for. Co-function of sine. So if I go from cos to sine, I just take the co away and I go to sine. So what is the co-function of tan? Put a co in front of the tan and you get cot, cotan. Or if I go from cotan and I take the co away, I just go to tan. What about sec? Cosec. Okay, and from cosec I just take the co away and I get sec. Ladies and gents, that is where they get it from. Co-function of tangent, cot. The co-function of sec, cosec. So there I've just taught you university style maths and you hopefully can do it quickly. Okay? Now ladies and gents, let's quickly look at tan of 360. I'm going to quickly talk to the ladies because the gents are way too lazy to do this. Quite a few of you guys are going to write here tan of 360 minus 45. Please don't do that. Guys, just write it for yourself beneath the tan because we don't give you any marks for it, so you're wasting time. Now tan in the fourth quadrant is negative. Why am I writing in red? I don't know. Okay, negative tan 45 degrees. I like to put my negatives in brackets so I don't forget there's a multiplication there. Now, ladies and gents, we're sitting with this thing where a negative squared is a positive, so this is cos squared A. But now, I can also, I'm getting sidetracked, I can calculate tan 45. Now let me quickly just make it real for you guys. I know a lot of you guys love your calculator. I see that lady there, she's got a calculator next to the, Ladies and gents, when you write your NBTs, you're not allowed a calculator. Now the second thing, which is scarier than that, sir, in your first year at varsity calculus, you're not allowed to take a calculator into a semester test or an exam. So you have to get used to doing trig without a calculator. So you've got to know your triangles or your special angles. Now, ladies and gents, we need to get back to the sum and ask ourselves, how can we simplify? By expanding the tan into sine of A over cos of A. And if I look at this one, it's going to become negative 2 sine A cos A. Again, I expand because I have no other choice. So I'm going to, that one divides away with one of those. That one divides away with that one. That sine A divides away with that one. At the top, I'm left with 1. Minus times by minus is a positive 2. Okay. Where do you guys lose your marks? Signs and identities. In these kind of sums, it's by signs and identities. Let's look at the second one. Now, the second one was absolutely beautiful. Okay? So the second one, ladies and gents, I'm going to follow exactly the same procedure. First, get my angles between 0 and 360. So I'm going to add 360 there. It might be different than the way you did it, and there's forgiveness for that. Sine 330, tan 225. Again, ladies, don't now go and write step by step what you do. Write it on the top. This is in the fourth quadrant, so it's 360 minus 15. So it's positive cos 15. Sine 225 or 255 is in the third quadrant. So it's 180 plus 75. So it's negative sine 75 degrees over fourth quadrant. So it's negative sine 30 minus third quadrant. So it's positive tan 45 degrees. Now, some of you, I don't know whether any of you guys did it, it happened this morning in the Afrikaans class, expanded sine 30 to become like 2 sine 15 cos 15. If you didn't do that, praise the Lord. I'm happy about that. You didn't do it. Guys, this is a special angle. So I'm going to work this out using special angles. If you struggle with remembering your special angles, please come and talk to me. I'll gladly show you a trick or two about how I do it. Now, cos 15 is an issue because it's not a special angle, but please don't go and expand it. Don't do 45 minus 30 because there might be something else you could do first. Now, what I would try and do in this case is try to get my angles the same And this would give me cos of 15 degrees. So this minus and that minus divides away, or becomes a positive, leaving me with cos squared 15 over a half, which is the same as 2 cos squared 15. Now, ladies and gents, doesn't that look familiar? That looks like a double angle identity. 2 cos squared theta minus 1 is the same as cos of 2 times theta. Well, that's 30. So my answer is root 3 over 2.